All right, example 3, 1/5 of all the clowns had red noses. If 30 clowns had red noses, how many clowns were there in all? So here's a technique for doing this problem. It's not the only technique. I'm going to show you a different technique on the next problem that you might like better. But here's a technique for this problem. All right, 1/5 of all the clowns had red noses. Now, before we read the next sentence, all right, pretend we haven't read the next sentence. In that sentence, do they give us any idea of how many clowns there are? No. Do they give us any idea of how many clowns have red noses? No, not because we haven't read past the period. All right, so we don't know either thing, right? So, based on this, I'm going to identify a variable for everything I shouldn't know at this point. So C is going to represent how many clowns there are. R is going to represent how many red-nosed clowns there are. And if I just take that sentence and translate it directly into an algebraic statement, an algebraic equation, 1/5 is the fraction 1/5. When you see the word of following the word of fraction, it's multiplication. 1/5 multiplied by C equals R. All right. What fraction didn't have red noses, by the way? 4/5, right? So if they started talking about not having red noses, then I could have made another one that looked like this. 4/5 times C equals N. That'd be not red-nosed. To me, that seems a little bit low. Every clown I ever see seems to have a red nose. I don't know. But maybe more of them don't. But anyway. But again, if they started talking about not red-nosed, I can make an equation like that also. So 1/5 did, 4/5 didn't. The two fractions should make 1. 1/5 plus 4/5 makes 1, right? So if we continue reading the problem, it says very clearly 30 clowns had red noses. All right? This could have also said 30 clowns did not have red noses. Then we would have to use this one, right? All right, so again, if we're going to use the equation technique, we've got to come up with an equation. We've got to consider a possibility of a different equation based on what information they're giving. So 30 clowns had red noses. That represents what R is, right? So I substitute what I know. 1/5 times C is equal to 30. And now it's my job to solve this equation. This is how many clowns were there in all. Right? So how do I solve 1/5 times C is equal to 30?
Multiply by 5.
Multiply by 5. Very good. So if I multiply the entire equation by 5, 5 times 1/5 makes 1 times C is C. 5 times 30 is 150 clowns. Okay. That is a technique for that problem. It's not very difficult to do. It uses algebraic equations to do that. Now, real quick, while I've got it on this page, let me show you the second technique you might like better. Same problem. I think I'll use both techniques on the next problem too, because again, they're both valid, they both work. So, 1/5 of the clowns had red noses. I see a ratio of some category having some characteristic. Okay, so I like to call this a categorical statement. All right? 1/5 of all these people that fit in this category have this specific characteristic. All right? And we can make the chart here. Okay, 1/5 of the clowns had red noses. So clowns is the big category, right? Always put the category at the bottom. And put characteristics above that. The characteristic they're telling us about is red noses, right? That looks like Ned nose. It's red nose.
Ed.
There we go, red nose. And then the opposite of the category, the opposite of the characteristic, I should say, would be not red nosed, right? Not red. Let's just go that way. So anytime they tell you something, 1/5 of the dogs were brown. Well, that means 4/5 of the dogs were not brown. So you can always have a characteristic and not the characteristic. All right? So the ratio they give me is 1/5 had red noses. So every 5 clowns, 1 had a red nose. That means every 5 clowns, 4 did not have a red nose. And they give me 30 clowns had red noses. How many clowns were there in all? So this actually isn't necessary. But we can create this ratio chart. 1 times C, that product equals 5 times 30. And that technique works also. Okay? So anytime you're dealing with a categorical statement, some fraction of some group had some characteristic, you can create a ratio chart that works also.